Today we're going to learn about 3D figures. 3D figures are made up of 2D shapes. 2D shapes include a circle, a polygon, a triangle, a square, and rectangles, etc. So the first type of 3D figure that is really easy to learn is called the prism. So the prism is made up of squares and rectangles. So all its edges are straight, and one example of a prism is, well, like that. So that is an example of a prism, and all of these edges are actually straight, and it's made up of 6 faces. So what's a face? A face is basically this part here. So the face is like the surface of the shape, the outside of the shape, where these lines here, the 4 lines, 1, 2, 3, 4, connect together and make a 2D surface, a 2D shape. This is called a face. Now, how much faces are here? Well, if we actually count them, there are 1. So let me just label this. 1 at the bottom, 2 at the front, 3 at the side, and 4 there, 5 at the back, and then 6 at the top. So there are 6 faces. Now, how much vertices are there? Well, how much vertices are there? Okay, so there's 1 vertex, 1 vertex, 2 vertices, 3 vertices, 4 vertices, 5, 6, 7, 8. Okay, so we have 8 vertices. So like that, and then right now we want to figure out the area of this prism. So we want not the area actually, the volume for this prism. So in 3D figures we call the area the volume, which is basically how much material does it take to fill this inner part of the prism up. So the volume V is equal to base times height. So what's base and what's height? Well, this is the base, and so this part is the base, the bottom part here, and this side is the height. So that's equals to base times height. Pretty straightforward, right? I mean, if you have a rectangle down there, and you know its area, and you move it up, you keep moving it up this much, then you went through the whole prism. So that's just the volume, base times height. How do you calculate the base? A lot of problems won't give you directly the base. It'll give you the length and the width. The width is this side here. Okay, so the length is this side here. So base is actually just length times width, because the base is actually a rectangle. Rectangles are equal to length times width. So that's actually equal to L times W times H. Okay, so moving on to the surface area then. We'll call the surface area S. What's a surface area first? It's basically the sum of the area of all the 2D faces which make up the prism. So we have 6 faces here. They're rectangles or squares. We want to sum the area of these 6 faces up. Okay, so how do we do this? Well, let's just try a few faces. So this face over here to the side has a length of W and a width of H. That face to the back, like this, also has a length of W and width of H. So that's 2WH. Then we add that to, So we add that to 2LH. Why? Because L is the length, H is the width in that triangle. In that rectangle, same as in this rectangle, same as that. So that's 2LH. As you can guess, we're gonna also add 2WL, which are the rectangles at the top and the bottom. That's the surface area. So that's pretty simple. Let's just move on to our next shape. The cylinder. So the cylinder. The cylinder is kind of like the prism, except for the fact that its base over here, this base here is a rectangle. Its base is a circle. So let me just draw that. So its base is a circle, like that, and then if it's a circle, then its sides going down are like that. So this is actually a curved surface. And the bottom is also a circle, that's the base. So what's the area of this? Well, firstly, let's just label a few things. This section is the height, and the bottom area is the base. The area, or the volume of the cylinder, the volume is base times height. Simple, right? Base times height. Now, what's actually base? Well, we know that this is a circle, so it must have a center, and it has a radius, r. Right? So we know that the area of a circle is pi r squared. So this is actually, the volume is actually pi r squared h. Okay, so that's our volume. What about the surface area? Well, the surface area, let's just call that S. So if you actually, I guess, dissolve the cylinder and make it 2D shapes, you'll get a circle, a rectangle, a circle, right? A rectangle, and another circle. Like that, and they roll together. So if you roll this up, if you make sure that this edge, if you take this edge to the other edge, you probably get like a cylinder or something. So that's the components, right? So we know the circles have a circumference of 2 pi r squared. So that's 2 times 2 pi r squared. That's 2 times 2 pi r, which is 4 pi r, right? Because the radius is r. So the circumference is 2 pi r. We have 2 pi r, which is 4 pi r. And what about the rectangle? That's our main problem. We know that the side is h here. And then this width here, or the length, is actually the circumference of the circle. It's actually 2 pi r. Why is that? Because, well, as you can see here, if you tape this edge to this edge, then the resulting shape underneath, the resulting shape that this length forms is actually the circle we get. So this wraps around the circle, and that has a length of 2 pi r. So okay, so the length is 2 pi r, the width is r. So yeah, 2 pi r h. So that's actually just our surface area. Okay, so moving on to the next shape. Our next shape is going to be a cone. A cone has a bit more interesting properties, so let's just study about this. So for a cone is, well, it has a base that is a circle, and so the top is actually just a point. So this is actually just like one point, and the base is a circle. The lines and the surface here connect. So the lines and the surface here connect the base to the side, to the point. So like that, so like that, and like that inside, etc. like that. That's the whole surface. So what's the area of the cone, the volume of the cone? the volume of the cone is, well, so this is base, right? This is base. The area of the circle times height, which is, well, so this is base and this is height. So that's the center of the circle, that's height. So base times height, well, that's obviously not correct, that's the area of a cylinder. But if we draw the cylinder like that, and if you actually do some stuff to this that I won't do here, but you'll figure out that the area actually looks like it's 1/3 of the cylinder. So that's just 1/3 base times height, which gives us, well, the area of the base is actually, sorry, the radius of the base is actually r, so it's pi, so it's 1/3 pi r squared r, and then pi r squared h, I mean. So that's our volume. What about the surface area? The surface area is going to be, so firstly the circle, the area of the circle is pi r squared. Secondly, the area of this whatever thing here, but if you open, so we don't know that, but if you open that up, you actually get a sector of a circle, so something like that, because if you wrap the bottom edge around, you get a circle, and, well, the length here from the point to the edge of the circle always stays the same. So this must be the radius, right? So that's just big R, or, yeah, that's just big R. Let's just call that big R. And the bottom here is actually 2 pi little r, because that's the circumference of our circle. So how do we figure out the area of this? Well, so essentially we want, I guess we want this angle, or we want, so to figure out this angle, we can use, so firstly, the radius is r, so the area is actually pi big R squared, right? And then, this angle over here corresponds to 2 pi r, right? Like for every angle you have in the circle, you can have a different circumference of the sector. So this 2 pi r is unique. So how do you use this? Well, you have 2 pi r, little r, over 2 pi big R. So that to that is actually, I guess, the proportion of this sector to the circle. So what you get here is actually s is equal to pi r squared plus pi, so pi, then this cancels out, the 2 pi's cancel out, pi big R times little r. That's actually the surface area. That's pretty interesting. So what about this length here? This length here, this radius of the circle, the big R. What's big R? Well, big R is actually equal to, you can use the Pythagorean theorem here, it's actually equal to the square root of r squared plus h squared, right? Like that. Okay, so, like that. Okay, so that's just the 3 things about the cone, and next time we'll encounter more complicated shapes, like, say, a tetrahedron, etc. So thanks for watching. Bye.